For 7.1, we're going to pick up a lot of formulas and different things with our trig functions. And when we get closer to the exam, you will be given more information of what will be given and what will be required of you. At the end of the day, I always think you should remember the basics, though. Things that you are consistently having to look up are going to be time consuming. But if you can at least remember these basics of the reciprocal identities like you were using in the previous chapter, and then the first Pythagorean identity, and then just be able to recognize that if you have something similar with your reciprocal functions or your tangent like this, that maybe you should check and see if you can use a substitution. So if you enjoyed some of those problems at the end of the previous unit where we were manipulating, changing things around, this is going to be your cup of tea. If you struggled through changing some of those up, then you might struggle here in these, but please reach out and let me help you and assist you. So I wanted to put this nice little graph at the top, and I wanted you to be aware of the things that we know and the things that we can do. And again, closer to exam situations, we will reevaluate and you will be given additional information of what will need to be memorized and what will be given as a reference. So let's just kind of work through some of these and see if we can recognize trends and patterns and things that we can manipulate. So we're going to look at a couple examples here, and I'm going to be using that graph from above. So if you printed out the notes to fill in, you have that right above there. If not, we'll keep referencing it. So the first thing I would do is I need to simplify this, and all it says is simplify to a basic trig function. So my two tips that I would give you in reference to working these problems is either one, convert back to your basics of sine and cosine. If you're not dealing with sines and cosine, go all the way back to your basic building blocks and see if that helps you. Or two, try and convert everything in the problem to the same type of trig function, and that helps you to better manipulate it. So you can see in this problem that the only thing that is not sine is this little piece here. And hopefully when you see something being squared, you think, oh, let me use a Pythagorean identity. So the Pythagorean identity I want to use is that cosine squared plus sine squared is equal to 1. I'm going to manipulate this until I get the cosine squared by itself. And I'm going to say, okay, if I subtract the sine squared from both sides, I get cosine squared x equal to 1 minus sine squared x. And so now I have a manipulation that I can do to plug in for this. And so I can come over here and I could say sine x times 1 minus sine squared x minus sine x. I'm going to distribute this out. This gives me sine x minus sine cubed x minus sine x. And because I'm taking sine x minus a sine x, those are actually going to cancel. And you can see in this problem, my final result would be negative sine cubed x. Now, what's really neat about these problems is this was the approach that I took, but I could also approach this a little bit differently, and I can show you how that rolls about. So in this one, I saw the singular cosine. I saw that it was squared. I used my Pythagorean identity, and I was able to get down to a single trig function. So I'm going to erase this. I'm going to work this another way. Now, if that way was really nice for you, then just stick with it, skip forward in the video, and roll on. I'm still going to leave my trig function up there, but let me work it again. For this one, what I want to do is, I see in this problem that I have two terms with signs on them, so I'm going to factor out a sine x, leaving me with cosine squared x minus 1. And I go, oh, cosine squared x minus 1 looks really similar to this over here, so let me manipulate this and plug this back in. So I want to create a cosine squared x minus 1 over here. And in doing that, okay, I'm going to leave the cosine x. I'm going to move this 1 over here, so I'm going to subtract 1 from both sides. So I get cosine squared x minus 1 plus sine squared x equal to 0. I'm going to subtract that sine squared over. And so I have a cosine squared x minus 1 equal to negative sine squared x. So now for this cosine x squared minus 1, I've got a substitution here. Making that substitution, I land on sine x times negative sine x, and then putting those together, I now get sine cubed x. So you can see in both ways that I worked that, I used the Pythagorean identity. I just used it differently. But as long as you are mathematically correct and you show all your steps, you will get full credit for a given problem like this, where we both arrived in both ways. We arrived at the same solution. We just manipulated it. And it's just going to be how you see it. Let's continue kind of working through a few more of these problems, because I want you to be able to see patterns and trends and approaches on how to work things. So let's look at the next one. I see that I have sine t plus cotangent t cosine t. So my best tip for this one is to revert everything to sines and cosines. I know that cotangent of t is equal to 1 over tangent. I also know that tangent is equal to sine over cosine. So if cotangent is the reciprocal of tangent, I know that cotangent is equal to cosine over sine. And I'm just kind of walking you through my mental process here on how I'm getting there. So that means over here I have sine t plus, instead of cotangent, I'm going to say cosine over sine times cosine. And so I'm going to clean this up. These are being multiplied together, so I get sine of t plus cosine squared t over sine t. And then from here, I'm going to do my fraction trick that you've seen in previous videos, and I'm going to put things together. So since the first one is not a fraction, I'm going to put it over 1 to make it a fraction. My fraction trick is I multiply this way, which gives me a sine squared t, plus I multiply this way, which gives me a cosine squared t, all over I multiply this way, which is a sine t. Hopefully things are going off right now in your head and you go, oh, sine squared, cosine squared. Let me go back up and use that Pythagorean identity. Remember, cosine squared plus sine squared equal to 1. And so now I can make that substitution here for this piece, and that's going to give me 1 over sine t, and that is the reciprocal of cosecant. 1 over sine t simplifies down to that cosecant. And so again, I just wanted to kind of show you the things that I'm kind of thinking through over here to the right, the pieces. And again, in this one, my best resource was taking it all the way back to sines over cosines and then working from there. Let's continue on this path. Let's keep simplifying up some stuff so I can continue to show some different methods and techniques. Example 3, we're going to simplify a trig expression to a single trig function. So all of these instructions are the same. So in this one, it says I've got a fraction plus a fraction. Everything is already in sines and cosines, and nothing is squared, so I can make some kind of Pythagorean identity substitution. So for this one, I'm just going to kind of work through this slowly and see if, as we get some pieces, if we can make some substitutions. Since I have the addition of 2 fractions, I'm going to go ahead and add these things, add them together by my fraction trick. So that gives me sine squared theta plus 1 plus cosine theta times cosine theta all over sine theta times 1 plus cosine theta. And that's just multiplying across the bottom. Cleaning up the top, I'm going to distribute this in, so that gives me sine squared theta plus cosine theta plus cosine squared theta. Hopefully you're already thinking, oh, Pythagorean identity. And then in the bottom, I'm just going to leave it as is, because typically if I have my denominator already factored out, I might see some cancellations later on. Now from previous 2 problems and that graph at the top, or the diagram kind of box at the top, we can see that that is our Pythagorean identity. So that gives me a 1. I'm going to make that substitution. So I have 1 plus cosine theta all over sine theta times 1 plus cosine theta. Now again, this is why I left it factored in the bottom, because this whole piece also exists in the bottom, so I can cancel that. I can cancel that because we're looking at multiplication in the bottom. You cannot cancel if you're just addition and go, oh, I got that piece and that piece. So this simplifies out to 1 over sine theta, and that simplifies up to cosecant theta. So again, you can see my basic building blocks of sine and cosines. I had to use my fraction trick. My Pythagorean identity came into play. Let's look at this one that's a little bit different, but we're going to revert back to some of our quadratic skills, as we work through this. And so let's talk about factoring with trig functions. If you see such as a squared term and a 1, you might want to think difference of two squares. When you go to factor this, what would multiply to give you secant squared? That would just be a secant times the secant. What would multiply to give you 1? That would be 1 and 1. And then because of that minus sign, we're just going to have a plus and a minus. And if need be, you can also think about this just as polynomials and go, okay, if I had x squared minus 1, how does that factor out? Well, that factors out into x plus 1 and x minus 1. And you saw some of this factoring at the end of the last chapter. So once I factor this out, you can see that I've got secant theta plus 1 times secant theta minus 1. And I've been able to factor that. And I'm not going to do anything else with it. But having that skill helps us to evaluate and possibly solve for theta based on if we're trying to find just theta or a triangle or an angle, etc. So this has given us tools to be able to break things down in a solving situation. Say I had one that looked kind of like a quadratic function. I've got a squared term, a regular term, and then no term or constant. Think of it as a polynomial. As you saw at the end of some of the last chapter, we did the same thing there in some of the homework problems. If you get confused, give your trig function a name. Let's call x equal to tangent theta. Make that substitution. That's 4x squared plus x minus 3. Then factor from there. This factors to 4x minus 3 and x plus 1. If you need help with factoring, reach out for assistance. So then you could just come back down here and say, well, that would be 4 tangent theta minus 3, and then tangent theta plus 1. And you've been able to factor this trig function. So you cannot forget all that we've done in previous chapters in relation to algebra when you move to your trig function. It's all going to relate. It's a slow build to where we are now. Let's do some that don't have all the same trig functions. This was just secant, this was just tangent. Let's look at example 5 here and see if we can work with something not with the same trig functions. Well, again, hopefully when you see functions like this that are squared, you're thinking, let me go see if I have a Pythagorean identity. I would like you to commit to memory the sine squared plus cosine squared equal to 1, because you can see I used it in the first 3 examples. But in this one, it's a cosecant. So I'm going to go back up to the beginning of our lecture, and I'm going to grab that identity. When I look for that identity, that tells me that 1 plus cotangent squared of t is equal to cosecant squared of t. And that's good news that it relates my cotangent, because I can see I have a cotangent here. So I'm going to make that substitution for cosecant, and I'm going to plug it in back over here. So that would give me 1 plus cotangent squared x minus cotangent x minus 3. And then I could put things together and go, okay, well, let's put the cotangent squared in front, minus cotangent, put the 1 and the negative 3 together, minus 2, and then factor that. And that factors simply. But again, if you need to come over here and make some notes and go, okay, that's an x squared minus x minus 2, and just factor it as a basic polynomial. So that'd be x and x. The back sign is negative, so they're going to be different. Well, to multiply to give me 2 and add to give me negative 1, that would be positive 1 and negative 2. Then you could jump back over here and write it with cotangent x plus 1 and cotangent x minus 2. Making little side notes as you go. There's nothing wrong with that. That does not mean you're not getting it. You're just seeing it in a simpler form to get there. Now we're just stopping here because these are expressions. These are not equal to anything. But let's look at some that if they were equal to something, how we follow through and finish that out. So here's an example. It says solve 2 sine squared t minus sine t equals 0 for all solutions with 0 to 2 pi. Now, some of you in the last chapters would skip over this interval, but that's important. That means we're only looking at the first rotation. And for this one, I already have this coordinate plane over here to the side because that's seeing a picture, drawing a picture, finding your angle in the right quadrant is where some of you lacked in the last chapter. So I'm going to work through this here. I'm saying, okay, you know what? Let me just come over to the side and think about this. This would be 2x squared minus x equal to 0. So just faced with that polynomial, I would factor out an x. And that would give me 2x minus 1 equal to 0. And then I could solve it from there and say, okay, well, x could be equal to 0, or 2x minus 1 could be equal to 0. I solve this out, and I get x to be 1/2. Now, that's all with a polynomial, so let's do it with sine now. So I'm going to factor a sine out, just like I factored an x out. That gives me 2 sine t minus 1 equal to 0. And then I'm going to solve it out just like I did over here when I solved it out. So I'm going to say, where is sine t equal to 0? And where is 2 sine t minus 1 equal to 0? So it gives me 2 sine t equal to 1 and sine t equal to 1/2. So now we need to come over here and think through where these occur. Going back to your unit circle, we are only going to be on 0 to 2 pi. So where does this equal to 0? Sine equal to 0? That only equals 0 when you are here and here. So that would be at 0 and pi. I'm not going to use 2 pi because it was not included over here. We're less than 2 pi. Where does sine t equal 1/2? Well, that occurs here when I have that value of square root of 3 over 2 comma 1/2. And so this angle would be at pi over 6. The unit circle is still your friend in this chapter. And then it also occurs over here when I have this angle that's 5 pi over 6. And so that means t would be equal to pi over 6 comma 5 pi over 6. So solve for all solutions. T would be equal to 0, pi over 6, 5 pi over 6, and pi. And I just listed them in numerical order. So we're really putting all of our skills during this semester put together. Let's do another one. Solve the trig equation. So the first thing I'm going to do is I am going to treat this similar to maybe a polynomial if need be. But it looks like I can't jump there because I've got sine squared, I've got cosine. So when I see this sine squared, I'm going to think of my Pythagorean identity and say, okay, well, I know that cosine squared plus sine squared is equal to 1. So I'm going to make a substitution here and say, well, then sine squared is equal to 1 minus cosine squared. So I'm going to say 2 times, instead of the sine squared, I'm going to make the substitution 1 minus cosine squared t minus 3 cosine t equal to 3. I'm going to combine like terms, clean this up, get everything over to one side. So I'm going to distribute the 2 in here. It gives me 2 minus 2 cosine squared t minus 3 cosine t equal to 3. I'm going to say, well, then that's negative 2 cosine squared t minus 3 cosine t. Subtracting that 3 over and putting together with my positive 2 gives me minus 1 equal to 0. Now, typically we like our quadratics to be positive on your front term. So I'm going to divide everything by negative 1 so that I get 2 cosine squared t plus 3 cosine t plus 1 equal to 0 because 0 over negative 1 is just 0. Now, if it makes you feel more comfortable now with your factoring, come over here and say, well, then that's like a 2x squared plus 3x plus 1 equal to 0. And then solve out from there. So this factors into 2x and x. What'll factor to give me 1? That would be 1 and 1. And then check it real quick. This would be a 1x. This would be a 2x. So that would combine to give you the 3x that you are needing. And then we're able to factor that. So we can come back over here to a problem and say, well, then that would be 2 cosine t plus 1 times cosine t plus 1 equal to 0. So now we're back to our trig circle. So I'm going to solve this out. I'm going to say 2 cosine t plus 1 equals 0. plus 1. So that gives me 2 cosine t equal to negative 1. So cosine t is equal to negative 1/2. On my coordinate plane, I'm going to think about where is cosine t negative 1/2? It occurs up here and it occurs down here. Based off cosine being your x value of your ordered pair, it being negative, I'm in quadrant 2 and quadrant 3. And so I want this angle here and I want this angle here. So that gives me, that gives me t is equal to, those two angles are 2 pi over 3 and 4 pi over 3. That's on my unit circle. Then if I take cosine of t plus 1 equal to 0 and solve that out, so cosine of t is equal to negative 1. Where is it at negative 1? Well, it would be at negative 1 here, which is all the way over, and that would be at pi. So I would say that is at t equal to pi. Now this says, the previous one, 0 to 2 pi, this one says all solutions. So this is where that k is going to come in that got y'all in that last chapter. So for all solutions, it would occur at 2 pi over 3 plus, if I rotate it around again, 2 pi, rotate it around again,